Welcome to the third and final part of our Module 1, General Networking Theory. In this module, we're going to look at the wonderful world of redistribution between our interior gateway protocols. We certainly want a routing world that contains no redistribution. But oftentimes, and definitely in the CCIE lab exam, we are going to be faced with redistributing one protocol into another. Maybe in the real world, we're merging with another organization, and we need to know all of their prefixes, they need to know all of ours. So as a temporary solution, before we go ahead and all use the same interior gateway protocol, we may redistribute information. Why do we dislike redistribution? Well, we lose information when we pass the prefixes from one routing domain into another. That's the real problem here. And when we lose this information, we could have suboptimal routing. Even in the worst case scenario, we could have routing loops or routing feedback. So we want to be very, very careful when we redistribute. What do I mean by we lose information? Well, just think about it. If we're taking EIGRP, it's a very complex metric of bandwidth and delay, and we're taking that information and putting it into the simple routing information protocol, we're going to lose all that information we gained in the metric. We had that nice sophisticated metric, and now we convert it to a hop count. So we lose information when we redistribute. Notice that redistribution is performed on our border routers, and these border routers, by their very nature and definition, they are indeed running more than one routing protocol. When we take the routes from the other domain and inject them into our domain through redistribution, we are dealing with external routes. Obviously, we have local or internal routes in our organization. By the way, in OSPF, this border router that's taking routes from an external domain and bringing them into our OSPF domain, it has a very special name I want you to know. It's the Autonomous System Boundary Router. I often see students miss that. They say Autonomous System Border Router, but it's actually the Autonomous System Boundary Router. When an area is a path between two other routing domains, we call this a transit routing domain, otherwise known as a doorstop. Yeah, your routing domain is now it's becoming transit for other prefixes to pass through. So this is typically something we want to be careful about doing, and we end up creating a transit routing domain between two others when we do bidirectional redistribution. Now, to contrast this concept of the transit routing domain, we have what's called a stub routing domain, and we're just going to inject prefixes into the stub. It is not going to be allowing traffic to transit it as it goes from one domain to another. So some key terminology here we want to master regarding route redistribution. Now, we made it clear that we do not want to do redistribution. We want to avoid redistribution if we possibly can. And one of the reasons we said that's true is because we lose information. And when we lose information, we can end up with suboptimal routing. We could also, at the very worst case, get a full-blown routing loop and routing instability due to feedback. Let's take a look at a topology and let's discuss exactly what could go wrong with redistribution. Fans out there of our blog site might recognize this topology. This is the topology that our own Peter Lepukov used on our three-part blog series that he did on redistribution. It's a fantastic blog item on the topic of redistribution. In a moment, I'll show you how you can find it very, very easily up there on our blog site, as well as other great articles involving redistribution. So anyways, as we look at this topology, we see that we have, quite a mess here. And by the way, something that would be a very typical topology for the CCIE lab exam. Notice there's an EIGRP Autonomous System 1, 2, 3 up top, then AS356 over to the right. In the middle, we have OSPF operating over the frame relay network cloud. And then at the bottom, we have RIP version 2. Here's something that could certainly happen. What if the RIP version 2 routes were to be passed by R5 into EIGRP AS356? The routes get passed into that AS, and then let's say they are injected into OSPF. So the RIP routes go into EIGRP and then into OSPF. Here's one of the problems. R4 will now learn the RIP version 2 prefixes from OSPF. It will believe the OSPF prefixes. And you know exactly why after our last lesson. That's right, administrative distance. The R4 administrative distance for the OSPF routes will say, look, OSPF is the preferred way to get to these prefixes. And now we have, at the very least, suboptimal pathing, don't we? R4 will be sending traffic for RIP. It's directly connected to the RIP domain, but it will be sending traffic for RIP up to R3 and over to R6, and it will, at the very least, feature suboptimal pathing. So we have a couple of rules that you are going to love to make sure you stay out of trouble when it comes to redistribution. The tools that I want you to be aware of for troubleshooting redistribution problems, specifically routing loops or route feedback that might result from redistribution, is first administrative distance. In that earlier example, we said that the particular router, it was R4, is going to prefer the prefixes that are learned from OSPF. One of the things we could do is for those prefixes, we could go ahead and we could say on R4 that those prefixes shouldn't be believed. We can manipulate the administrative distance of OSPF so that the RIP routes are preferred. One thing that we might want to consider is filtering. Let's not allow those routes to be advertised into a particular protocol or to a particular router. And obviously, we want to be very, very careful when we engage in redistribution to avoid suboptimal pathing and routing loops, as we have described. Here are two great rules of thumb that you want to use for redistribution to avoid such problems. Number one, you should remember that routers should always prefer their internal prefix information over external pref information. That R4 router on the last slide was a great example. It should prefer the RIP stuff that it's local to, as opposed to believing OSPF for the RIP information. And then another great rule is an overused term in Cisco networking, but we refer to it as the redistribution split horizon rule. And what this means is, look, we should never redistribute a local prefix into a particular domain that we're neighboring with and then accept the same prefix from that domain. And that's essentially what R4 was doing there. It's part of the RIP domain. It's helping to advertise this information into another domain, and then it's accepting information about that prefix back. So these are great rules of thumb that are going to keep us out of trouble when it comes to redistribution. Now, redistribution is certainly a vast topic, and you probably are going to want to get some more information on this topic. Well, I wanted to share this tip with you. It's our blog site. You should subscribe to the blog, and you should be looking at each and every article that is posted to the blog when it happens using an RSS feed. But for those of you that are wanting to go backwards and get information out of our blog, here's a great tip. Just go to Google and type in blog.internetworkexpert.com and then your search terms, and allow Google to very efficiently search our blog for you. Notice I did that here using the keyword of redistribution, and we were led to great articles involving the topic, including Peter Lepukoff's 3-part series on redistribution that I really think you should enjoy, and that's an easy way to find those 3 parts. So enjoy the blog site and use this tip when it comes to searching our blog site for information. Excellent job, everyone, on this third and final lesson for our General Networking Theory Module 1.